Well, good morning, grade 11s. And as promised, there was what I gave you yesterday wasn't really. I get 3 hours of your time a week, right? So maybe yesterday would take about an hour to do everything. I don't know. That's probably generous, but yeah. And today's stuff isn't too bad either. It's just still reviewing what we did in grade 9 on electricity, or what you would have done in science in grade 9. And so I'm just going to get right into it and just explain a couple things. And then there's a worksheet that doesn't take very long. It's we got maybe 10 questions on it or so, but it's the calculations are very easy, very quick. Okay, so I'm just going to define these terms for you that I put at the top: charge, voltage, current, and power. Okay, so let me start with charge. Sorry, my pen is a little faulty. I gotta fix it, but I've ordered a new tip for it. It's getting a lot of use. Okay, let's start with charge. All right, so we already know that charge is when you add and subtract electrons from an object. Positive charge is when you when you subtract electrons from a neutral object, you get a positive charge. When you add electrons to a neutral object, you'll get a negative charge. But how do you measure charge? Okay, so usually they don't do this in grade 9, so I'm gonna do my best to define this for you. Charge is here. The unit of charge, I'm going to explain this, is a coulomb. Okay, and 1 coulomb, it's a bit hard to define, but a coulomb is basically the amount of charge that flows out of a 1 amp source in 1 second. Now, it turns out a coulomb is actually a relatively large amount of charge, but that is the standard unit of charge. Like, just to give you some sense of it, a lightning bolt might have 20, 30 coulombs of charge in it. Okay, so a lightning bolt, 20, 30 coulombs, that's all. Like, so like if you want to think 1 coulomb, if a lightning bolt had just 1 coulomb, it would still kill you, okay, if it hit you. So 1 coulomb, actually a massive amount of charge. When you rub a balloon on your head or whatever, and that gets the amount of charge, that maybe is a millionth of a coulomb on there. So it gives you some sense of what a coulomb really is. If the balloon had 1 coulomb on it, it would kill you to touch it. Okay, like, so it's that'd be a massive. It could never do it. Like, you could never hold that kind of charge. It would dissipate into the environment before it ever built up to that level. The static ball has again millions of a coulomb on it. That's the Van der Graaf machine. It makes your hair stand up. So coulomb, and we just capital C for coulombs. Okay. And I'm going to tell you this as well, that this guy named Millikan did an experiment that we'll look at in grade 12, but he did this experiment about 100 years ago. And the question was, what is the charge on an electron? Okay, so this is called the elementary charge. What is the smallest possible charge you can give something? Well, it's 1 electron, right? So this is the charge on the electron. We're going to call it little e, is 1.602 times 10 to the negative 19 coulombs. Now, that's for an electron is negative. On a proton, okay, so a proton charge has positive E, which is positive 1.602 times 10 to the negative 19 coulombs. Now, you see how small that number really is. 10 to the negative 19 is a very small number, okay? But, you know, all charges, okay, are multiples of this. Okay, of this charge. Now, what does that mean? Well, I mean, the smallest charge you can give something is 1 electron, right? If I give it 1 electron, now it's got a small negative charge, and this would be its charge, 1.602 times 10 to the negative 19. Now, if I gave it 2 electrons, okay, then it would have twice that charge. Okay, so it's have to be multiples. All charges are multiples of this number, and that's what Millikan showed 100 years ago, was that all charges really are multiples of that number, and he did it by measuring really, really small charges on little tiny oil drops. Okay. All right. So anyway, all charges can be written therefore like this. Q, we use Q for charge in physics, small q. Okay, that's the variable for charge. And that has to equal NE, where N is the number of excess or deficit electrons on an object. And of course, E is 1.602 times 10 to the negative 19 coulombs. Okay? And the way it works is if it's an excess, it's a negative charge. If it's a deficit, it's a positive charge. And we just use this number and write it as a positive number, and you decide whether it's excess or deficit based on whether the charge is negative or positive in the problem. Okay? So that's how you measure charge. Really that simple. Okay? Charge is measured in coulombs. So that takes care of charge there at the top. Now we're going to define voltage, current, and power. I'm going to start with current. So here, we'll call this number 1, charge. Number 2, current. Current, really cool, is the flow of charge. Just like current in a river is the flow of water, while current for electricity is the flow of charge. Okay? And there's 2 kinds of current. There's DC, which is short for direct current, where the charge flows in one direction only. Okay? AC stands for not air conditioning, but alternating current. Okay? And if we did the circle of pain at school, which some of you know what that is, you'll feel that, and what happens is the electrons flow back and forth. Okay, a river is like DC. It's, water flows from high ground to low ground. Okay, and there's really no equivalent for water for alternating current. Okay, so that's where it gets a little weird, but just picture the electron kind of vibrating in the wire back and forth. Okay. Okay, so that's it. Alternating current, direct current. Now, how do you measure charge? Well, either way, it doesn't matter what kind of charge it is. We use I for current, okay, in physics, and it's equal to the charge that's flowing divided by time. Makes sense, right? Like it's a flow. So how do you measure, like if you were electrons and you were walking down the hall, I could say, okay, what's the flow of students in the hallway? Well, it would just be the number of students that pass by my door, let's say, divided by time. And it'd be, so many students per second, right? So the unit of charge is equal to coulombs per second, which would be logical to you. But we named this in honor of a famous scientist whose last name was Ampere. So we use amps, or A, okay, capital A for current. So 1 amp, okay, is 1 coulomb per second. Okay, that's it. All right, number 3, voltage. Voltage is the energy per charge. Now, energy is measured in joules, as you know. Okay. Now, sometimes voltage is also called potential, okay, or potential difference. Okay, so when you see this word potential or potential difference, it means voltage. Now, sometimes the word potential energy is used. Well, that just means energy, okay? But potential by itself, without the word energy, means voltage when we're talking about electricity, okay? So it's the energy per charge. So these electrons are flowing through a wire, let's say. Each unit of charge carries a certain amount of energy with it, okay? It's like a lightning bolt. Each coulomb might carry like 1,000,000 joules of energy in a lightning bolt, okay? So the way it works is the voltage, and I'm going to use this V with, I sort of make it a capital V with that little hat on top of it there. Voltage is equal to energy per charge, right? Q is charge, E is energy. So E is energy in joules. Q is charge in coulombs. Okay, and therefore the unit of voltage, okay, unit of voltage is equal to joules per coulomb. But again, we name this in honor of a scientist who invented the first battery, okay, Alessandro Volta, okay. So we just use a capital V for volts, okay. So 1 joule per coulomb equals 1 volt, okay. And that's it. So that's current, that's voltage. Just got one left on our list, okay, at the top, power. Now power we've already seen. Number 4, power, okay. So power, we already know what power is. Power is the rate that energy is being transformed, or its work over time, or energy change in energy. Remember how we did work was equal to the change in energy, so it's work over time. Its unit is joules per second, which you know as watts, right? So 1 joule per second equals 1 watt. All right, so that's power. We already know power. It's all good, okay? However, in electricity, if you take the definition of current and the definition of voltage, watch this. Voltage times current equals energy divided by time, divided by charge, pardon me, is voltage, times charge divided by time is current. So this one here, I'll put in 2 brackets. That one is voltage, that one is current, okay? The Q cancels out, and you get energy over time. Well, that happens to equal the definition, I'll just circle it here, that's the definition of power. Okay, so therefore what I've just proven to you is power for electrical devices is voltage times current. Okay, and I'm just going to put a little box around that. All right, so now you know the definitions of charge, current, voltage, and power, okay, in terms of electricity. And I did all of this in grade 9. Okay, you may have forgotten all of that. It's a couple of years ago. So yeah, now this is a worksheet that I probably gave the same one in grade 9, but many of you were not in my class in grade 9. And so this is for review, and for some of you it might be new. I gave this worksheet, okay? Very quick, very easy calculations. Like look, 5 coulombs of charge pass a point in 2 seconds. Well, since current is just charge divided by time, just 5 divided by 2 is 2.5 amps, okay? As simple as that. Here, current of 0.3 amps is activated for 20 seconds. How much charge flows through the circuit? Well, it would be just solve the equation for Q. So Q would equal current times time. So 0.3 times 20 is what, 6 coulombs, whatever it is. Very easy. Now, I just want you to notice sometimes we use the metric system here. So little ma, what does that stand for? Well, that stands for milliamps. And just like a millimeter is 1/1000th of a meter, this is equal to 10 to the negative 3, which is 1/1000th amps. Okay, so you have to divide this number by 1,000 to convert it into amps. You must do that first. So look, it says here, don't forget to change the unit with. You need to change it so it has no prefix. In other words, you have to convert the ones with a prefix, a metric prefix like milli or kilo or whatever, to the standard unit first, okay, without the prefix, before you do the calculation. Now, just for reference, I included a metric conversion guide over here. So which ones come up most often? Well, this one, giga, comes up very often. Mega means a million, okay? Okay, so these are the powers of 10 that goes. The kilo means 1,000. Okay, I think you know that. Deci almost never comes up. Centi doesn't come up in electricity very often. 10 to the negative 2 comes up when you're measuring things like a centimeter. It's the only time you see it. But milli comes up all the time. We just saw it. Milli means 1/1000th, or 0.001. Micro comes up with charge. Because remember I said a balloon will have a microcoulomb on it, which means like a millionth of a coulomb. So it's 0.000001. Okay, that's 1/millionth of a coulomb. There's microcoulombs. And notice the symbol is a Greek letter mu. That's not the letter U. That's a Greek letter mu. Okay, and we've used it for the coefficient of friction before, but here it's used as a prefix in the metric system. All right, so now that you've got this information, you should be able to complete this worksheet. This one here, I'm just going to remind you, work. So from the last unit that we did, don't forget that work is equal to force times distance. Okay, so that's how you find that one. Okay, and I think there's a couple of questions on work and force and distance, but this is review. We've already done this. Okay, here's microcoulombs. So what you would do if you wanted to write 10 microcoulombs and write it in coulombs, you would write 10 times 10 to the negative 6. So what you do is you go over to the table. Micro means 10 to the negative 6. So just replace the micro with times 10 to the negative 6, and now you've converted it into coulombs. 1 millisecond here would equal 1 times 10 to the negative 3, because milli means 10 to the negative 3. Okay, so just make sure you convert those ones with a prefix into standard unit before you go ahead and use them. It comes up a few times. I don't think it comes up very often, to be honest with you, but it does come up. Okay, so this worksheet, I would say, with these 19 questions, I thought there was only 10, but really, like, they're all one step. So like you could go through this, okay, like for example, I could go through this and do the work ones, just force times distance, right? No problem. What is the potential difference? So voltage is equal to energy over charge. So you just go 350 divided by 5. Just use the formula. I would say half an hour at most, okay, to do this. And it's a nice little review of the basic units of measurement in electricity. All right, that's it for today. So guys, please do this worksheet. Sometime next week, we'll have a little electricity test, okay? And I don't think I've used my 3 hours yet of your time this week, so I think I'm going to do one more lesson before the week is out. Yeah, we'll move along through electricity. Most of it is review of grade 9. We're going to do circuits next, and circuits is, we did that in grade 9 too. So anyway, we'll just go through it. There will be some new and more difficult problems compared to grade 9, but we'll get through it. It's pretty easy. All right, so have a good day, guys. We'll talk to you soon.